Alright, hi everyone, welcome to my YouTube channel, CTF Lectures. And in this video we are going to do something really interesting. We are going to work on some past question papers, and you know how important that is for a student, past question papers. And yeah, in doing that we are going to get to this. Okay, so yeah, we're going to do everything here, really interesting. So let's go. Now imagine we are asked to design this thing we have here. It's actually an intruder alarm. Yes, I know the name sounds fancy. Intruder alarm. That's if someone is of course an intruder, the alarm will turn on, and then the light will turn on also. So how do we design this? Okay, how do we design this? First thing is to do this. That is, here we are asked to give a block diagram of it. Okay, and that is literally the application of a microprocessor. So this is the block diagram of what we have right there. Okay, so now let's say we are asked to design this. Okay, we should provide a block diagram, then explain the components inside of it. Okay, explain the components we have in a block diagram, and then give us the circuit diagram. Of course, what we have here is the circuit diagram. I know this looks complex, okay, but it's actually simple. However, what we are asked to do in the equation is the intruder alarm, when it detects motion, is going to trigger or turn on the buzzer, which an audible something audible you can hear, which is or something like that. Then turn on flashlight, okay, and then send message. So we need a GSM model. Send message maybe to the security man or to somebody in charge, that kind of thing. So the thing is actually just simple and straightforward. This is it. The motion sensor, which is PIR motion sensor, okay, passive infrared motion sensor, it senses motion. Okay, and not just senses motion, it senses heat. Okay, heat, yeah, and of course humans, we have produce heat. So this, yeah, I wrote it down here. So it detects intruders present and movement. How this works by detecting infrared radiation, which is emitted from objects that generate heat, and that's human. So in this case, the intruder. So when someone gets to that area, okay, when someone gets to that particular restricted area, the motion sensor of course will detect the person and then send signal. Okay, the person being detected, this, when the person gets to this range, it will detect it, and that will serve as input to the PIR sensor, which will now give output, okay, from the sensor. But this output is from the sensor, is actually input to the microprocessor. Are we seeing what's happening? Okay, so it will serve as input to the microprocessor. That what will happen next? The microprocessor receives this as input and processes that signal. Of course, we'll give instruction to the microprocessor, okay, what to do with the signal. Processes that signal and give output signal to output devices, and that's what we have: buzzer, flashlight, and then GSM model. Okay, so I think I've explained everything there. This is so the components we have here, okay, evaluation of the scenario, which is all I've just explained. Motion sensor, I've talked about it. The microprocessor, okay, it receives input signal from the PIR motion sensor, process it and gives output signal to output devices like the buzzer, flashlight, and GSM model. Then the buzzer, okay, generates audible alert when it receives signal from the microprocessor. Flashlight, it illuminates the intruder's detected area, of course, yeah, detected area, when it receives signal from the microprocessor. And of course the GSM model sends alert to the security officer when it receives signal from the microprocessor. And yes, our power supply, I forgot that part. Power supply, of course, this just gives the necessary electric power, okay, electrical power. electric power to the entire system. And then of course we need wires. They are used to make the connection between components. So this is just it. Okay, then what we have here, okay, this is the circuits. Should I call this the circuit diagram? This is actually the connection. However, I do not have a GSM module here. I do not have a GSM module here. Okay, there's no GSM module here. Okay, maybe I'm typing that thing wrong, but guys, let's just work with what we have. Okay, note I'm using this site Wokwi. Okay, Wokwi, so you can just try that out. But if you have these physical components and you want to build them, fine, that's okay. And this is the code for it. Is a code for it. Very, very simple and straightforward. Now this code is based on our connection here. Okay, so yeah, should I do that in this video? Yes, let's just quickly do that. So now look at this. Light, which is our LED, is connected to pin 13. Look at it, LED pin 13. Are you seeing it? Pin 13 of the Arduino. I connected it through this resistor, of course. Okay, so that's the anode. Then of course the negative side is connected to ground of this guy. So look at this breadboard. I just connected everything here is connected to ground. This line here, are you seeing it? All this line connected to ground. So anything in the breadboard that connects to this place is connected to the ground of the Arduino. Same thing for this line. This is the 5 volts of the Arduino. Anything connected to this rail is connected to the live. That is the 5 volts of the Arduino. Okay, so now, yeah, the LED, I connected it to pin 13. You can see it here, light, pin 13. And then in the setup, pin 13 should be what? The pin mode of 13 should be what? Output. Meaning Arduino will be giving output from this pin. Output to what? To our LED. Okay. Then for the buzzer, I connected it to pin 12. Pin 12. You can see it. Pin 12. Okay. Pin 12. Of course, the other side goes to ground. So pin 12, that's for the buzzer. And it should be what? The mode of the pin, should it be output or input? We said it should be output because it will give output signal to it. Then for our sensor, look at it, it's in pin 11. Okay, pin 11. Note, it's the middle pin of the sensor. The positive goes to the 5 volts of the Arduino. Are you seeing it? 5 volts of the Arduino. The negative goes to the ground of the Arduino. Okay, but this center, the one in the center, goes here and it serves as the input. When it senses movement, it gives this signal as input to the Arduino. That's why we set the pin mode of the sensor towards input, and that's pin 11. Okay, so with this we have gotten this first part of it. Please, if you are wondering, let me just pause here and quickly say this. Okay, how do you get your IDE for Arduino? That's why I have this tab open here. This is not my YouTube channel, this is Sun Founder. Okay, like this guy is super good. Anything Arduino, guys, I recommend this guy's YouTube channel. Okay, so on this video here, he gives a tutorial on how to set up your Arduino IDE, okay, for absolute beginner. This is the one I watched to get mine working. I have an Arduino IDE, I've downloaded it, but I'm just using Wokwi now because it gives me access to all these tools and, you know, simulates them. So you can check out this guy, okay? And he has other videos too on Arduino. In fact, he has a playlist on it. Yes, this is a playlist, Arduino tutorials for beginners. He has a playlist on Arduino. Okay, so let's continue with this. So the basic programming of Arduino, all these things, C++, you can check out that guy. Okay, so let me just continue with this now. Yes, so these first parts, okay, setup parts, this is the part where we set up the state, set up whether it's the pin should be output or input, which we have done. Then this other part, what we did here in the same setup function, what we did here is that the initial state of the output for digital write, for the light pin, the initial state, should it be on or off? Low means on. I'm sorry, low means off, high means on. So when we have not received signal from anything, it should be low now, like it should be turned off. That's why we just did this, to avoid that floating state. That means the Arduino will not know whether to send high or low to it. So we just say, for now, since you have not received anything from the sensor, it should be what? Low. The same to the buzzer. No tune. If we say tune, it means, it will ring when it will ring for a start, and we don't want that. For a start, there should be nothing unless there is motion, somebody move, we see the intruder, okay, or it detects the intruder. So we'll close the setup. This is the setup part. And then for so for this other part, there are two main functions in this code: the setup, which is this, and then the loop. So the loop, this is the part that runs repeatedly. Okay, so the first thing we'll do here to check the input from the sensor and save it as a motion. You can use any name here, you can use anything here, okay, but whatever you use here, it should be the same thing here. Okay, let me just leave that because this is kind of relatable. So digital read, to read what is in that digital pin sensor. Remember we have said sensor is what? Pin 11. What's this? Pin 11. Okay, pin 11. So digital read, meaning we read what's there. So if this detects motion, it will send something. It will send high, that's 5 volts to this part, okay, or something within that range of something that is not 0 volts to that pin, which is input pin. So now we are saying that high sent here, it should be saved in this place. Now if the motion, which is this, equals high, that means if it's the same thing as high, what we have in the motion, what it read, if it reads high, that means if it's the same thing as this, what should happen? We'll do what? Set the light to high, meaning turn on the light. So digital light equals high. So remember high, light is what? Pin 13. So digital light, we'll now say pin 13 should now what? Receive what? High. So we'll now send high to this, which is 5 volts. Okay, so this guy will turn on. I will simulate it, so we'll see what all I'm saying. Then for the buzzer, I will say tune, meaning it's the Arduino will send voltage like back and forth, that kind of thing. When I say back and forth, I mean that kind of frequency oscillation, and when that happens, it will cause what? Sound. So that's the function for this tune. So this 300, it can be any number, but the lesser it is, the lower the frequency. The higher it is, the higher the frequency, and so on, just like that. Let me use 800, that frequency higher. Let me use something low, 200. Okay, so yeah, turn on the alarm. Else meaning if this is not the case, if motion is not high, else digital right, the light should remain off, low, the buzzer no tune. Okay, and then we wait for 0.1 second. We can wait for any number of seconds, but the thing is that the Arduino receives input from this guy, from the sensor, okay, and works with that input. Then just wait for a little second, then takes another input again and works with it. But if we say let's remove this delay, okay, we just mean that the Arduino, after taking the input, it will not wait for any time. It will go again to the sensor, collect input again. After run this one, go again, collect input. It will not wait. But we're just saying that at least just maybe hold break, okay, and just a little break. Alright, so let's simulate this in and see what happens, and then we'll close the loop, of course. Alright, okay, so it's on. Then we just click this to simulate the motion. Simulate motion, yeah. So now this simulate motion just mean that imagine somebody's moving. Okay, someone moves and maybe close to the scene, get detect motion. it will sound. Watch. Now it goes off because there is no motion again. But if I motion, there is motion, 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 the guy is still moving, he's still moving, still moving. You see that the alarm keeps on, it's still on. Okay, let me just wait. I think it should go off very soon. Yeah, so that's how it works. So this guy, like I talked about, if we increase the pitch, and that's just okay, but that's that. This is going to give us a higher pitch, which is really unpleasant. Okay, let's go. Yikes, that's okay. So okay, hope we get the gist. So this is just it for this project. Like I said, I just skipped that and GSM model part, and this is what we have for it here. Okay, so this covers the idea of this motion sensor and the evaluation of the scenario and the parts, various parts of it. Okay, so yep. Then one other thing in the past question is to sketch the internal architecture of the 8085 microprocessor and write down its features. Now we have done that in one of our videos. We have done that already, and this is it right here. Okay, so the internal architecture. So instead of me to repeat the whole thing, I'll just leave a link to that video. So you can just watch it right there. Okay, so I think this will be all for this video. I think that's it. For this video. Okay, this will be the next video. Okay, so that's all. Like, share, subscribe, and comment, and thanks a lot for watching. See you in the next video.